Welcome to the Explainer. Okay, so let's just dive right into this. Listen, if you only know how to turn your computer on, you are in the exact right place today. We're going to figure out how to demystify SQL together and take you from absolute zero to a totally confident database user.
Have you ever actually wondered why massive platforms like Netflix, Instagram, or ChatGPT don't just save all their user data in a simple Excel file? I mean, it seems a lot easier, right? But honestly, when you're dealing with millions or even billions of interactions every single day, the reality of modern tech demands something infinitely more robust.
So here's our game plan for today. We're going to cover the need for databases, relational versus non-relational structures, mapping out database architecture, unpacking CRUD operations, and finally, mastering actual SQL queries.
Kicking things off with Section 1, the need for databases, moving beyond files.
Look, old-school paper files and basic desktop spreadsheets, they just can't handle today's data needs. While Excel is a fantastic tool for everyday tasks, like budgeting for a small project, it absolutely crashes and burns when you hit millions of rows. Think about it. Your computation times basically grind to a halt, and instantly retrieving specific filtered data becomes a total nightmare. And that is exactly the problem that a database management system solves. It stores data in a format specifically optimized for instant retrieval, no matter how huge the file gets.
Moving right along to Section 2, relational versus non-relational. Choosing your data structure. So we basically split these massive systems into two main camps based on how they organize information. First up, we've got relational databases, like MySQL. You can think of these kind of like a bank, strict, precise, and totally rule-based. Data is structured neatly into predefined tables, columns, and rows, and everything is logically linked together. Then, on the flip side, we have non-relational databases, like MongoDB. These are way more like your social media feed, flexible, fast, and free-flowing. They don't enforce a rigid schema, which makes them super optimized for heavy read operations. But for our journey today, we're going to focus entirely on mastering that structured relational side with SQL.
Okay, Section 3, database architecture, the folder analogy. Let's make this abstract tech concept super tangible, okay? Think of the database itself as your main master folder on your desktop, or maybe a big overarching Excel workbook. Inside that main folder, you have tables. These are literally exactly like the individual files inside that folder, or the different tabs in your workbook. And then, finally, the rows and columns inside those tables, that represents the actual raw data. That's the specific info you're trying to store, whether it's a list of customer names or a massive inventory of products.
Which brings us to Section 4, CRUD operations, the core actions.
So how do we actually interact with all this nested data? Well, it all boils down to one foundational tech acronym, CRUD, C-R-U-D. That stands for Create, Read, Update, and Delete. Honestly, every single time you use an app, whether you're making a new user profile, scrolling a timeline, changing a password, or deleting an old photo, you are triggering one of these four fundamental actions in a database somewhere. It governs absolutely everything we do.
But hey, before we can just unleash those actions, we need to set the rules of the house for our tables. And we enforce these rules using data types and constraints. Data types tell the database exactly what kind of data is allowed in a column, like int for numbers or varchar for text. Constraints, on the other hand, are the strict rules we apply to keep data clean. For example, a primary key ensures every single row has a unique identifier. Not null ensures a crucial field, like a name, can never just be left blank. And unique guarantees no two users can register with the exact same email address. Without these strict rules of the house, trust me, our data would turn into chaotic, unusable garbage.
All right, the moment we've been waiting for. Section 5, Mastering SQL Queries, putting the hero into action.
Let's actually dive into the syntax and see this in action. Here's our very first query, which handles the create part of CRUD. When a developer types insert into users values, they are literally giving a direct, explicit command to the database to add a brand new record into the user's table. In this case, we're giving this new user an ID of 1, the name Alice, her email address, and a salary of $65,000.
Now imagine running that insert query a couple of times. Suddenly, our raw data is perfectly organized into strict columns and rows, based completely on our house rules. We've got Alice successfully logged in at ID 1, and we've successfully added ROV right there at ID 2. It really is that simple to start populating a database. Okay, next up, let's explore the read operation. This is where SQL's true power is just an absolute game changer. Take a look at this query. Select star, which is SQL language for all columns, from users, where gender equals female and salary is greater than $60,000. Think back to those Excel limitations we talked about earlier. Even if this table had 10 million rows, this specific SQL query instantly filters the exact records we need without even breaking a sweat.
And boom, the database instantly fires back only the precise data that matches our exact logical rules. Alice is returned because she perfectly satisfies both of those conditions. Whether a business is pulling a highly targeted list for a massive marketing campaign or running some complex payroll operation, this instant, flawless accuracy is exactly why databases run the modern world.
But wait, what happens when data changes over time? That's our update operation. Our query says, update users, set salary equals 45,000, where ID equals 2. We are specifically targeting Arav by using his unique primary key ID. And let me tell you, this is a developer's absolute lifeline. If you forget that where clause, you might accidentally change the salary of every single person in the entire database. Definitely not a good day at work.
But since we used it, instantly, Arav's salary updates to 45,000 in the system. This just demonstrates how seamlessly and safely SQL handles dynamic data adjustments in real time, all without disrupting the rest of the database.
So, we've successfully created, read, and updated records in a single table today. Pretty awesome. But here is a final, provocative thought to leave you with. In the real world, data almost never lives in isolation. If we have a users table holding all our customer info and a completely separate orders table holding our sales data, how on earth do we intelligently link them together to see exactly who bought what? Well, the answer lies in foreign keys and joins, which is going to be your thrilling next step into the advanced world of data science. Keep practicing your queries, and I'll catch you in our next explainer.